Hey everybody, today we're going to talk a little bit about angles and arcs and then circles. So here's the notes for today's topic. The first thing you're going to notice is we have a circle here, and there's a whole bunch of things drawn here. We have what looks like a bunch of radii drawn. We have ML, MR, and MZ, and these form sectors of this circle, okay? And the first term we want to know about is called a central angle, okay? And a central angle has the center of a circle as its vertex. Okay. And the sides, I should have used a blue pen for that. The sides are 2 radii. Here, I'm going to use a different color so it's a little easier to see. So you can see here that this would be a central angle, this would be a central angle, and this would be a central angle, which we'll show you. So for example, angle, let's see, is this going to work? I'll do this one. Central example, it's right over here. Central would be central angle. Angle LMR. Another one would be angle LMZ. Another one would be angle RMZ. And those would be examples of central angles, okay? Okay, a minor arc. Now, there's different types of arcs. Arcs are actually the pieces of the circles. For example, this is an arc, this is an arc, this is an arc, and you could go from here to here, or here all the way around this way. Now, there's a way to if I was to say arc ZR, I know we're talking about this smaller arc here. If I want to talk about this larger one, I'd have to use this letter in between, so I'd have to say arc ZLR, which we'll get to right now. Okay, so, also by the way, all these central angles here would add up to 360 degrees, obviously. The sum of these would be 360, because that's how many degrees are in a circle if you would rotate all the way around. So a minor arc is an arc that measures, yeah, it's easier to see that, measures less than 180 degrees. So an example here would be, arc, yeah, we'll say arc RZ. So the way you draw an arc is you draw the letters, and you do that look like a little part of a circle, almost like it looks like an arc. It is specifically an arc. Also, LR would be one, and LZ would be one. Those would be minor arcs. Okay, a major arc is an arc that measures greater than 180 degrees. Okay, an example of that would be, let's say, Z to L to R. So ZLR, that'd be one. Or ZRL would work as well. Okay, so we go ahead and a semicircle is an arc that measures exactly 180 degrees. In other words, it's formed by actually like a diameter. So the chord forming it would be a diameter. So we're going to make a new one here. We're going to go ahead and extend this. We're going to go through here. We're going to call that B. So semicircle, the arc would be, let's call it BZ. Example here would be BZ. Okay. So again, arcs are pieces of a circle. Minor arcs are less than 180 degrees, and major arcs are greater than 180 degrees. Okay. This is the notation we use. And central angles are actually, the central angle and the corresponding arc will be the same measure in terms of degrees. So for example, if angle, let's say BMR was 70 degrees, well that means arc BR would also be 70 degrees. They are going to be the same if it's a central angle. When we get to inscribed angles, that's going to change. All right, let's go down. Oh, the camera froze. Let me see if I can fix this. Okay, crisis averted. Here we go. So let's look at this example down here. I'll zoom in here. And the exercise is asking us to find the measure of angle AOD. So AOD is this angle here, right? That's the angle we're looking for. And we can solve for that. So let's go ahead and look at this. So we have three measures given to us. We have 25x degrees, 3x degrees, and 2x degrees. Now if you notice, this is a diameter. AB is a diameter, which means arc AB, or ADB, or however you want to call it, is a semicircle, which means this arc is equal to 180 degrees, which means these corresponding angles that consist of this arc would also be equal to 180 degrees, which means we can solve this algebraically. We're simply going to add these together and set them equal to 180 degrees. So we're going to say 25x plus 3x plus 2x equals 180 degrees. And we're going to go ahead and solve that. So we're going to go ahead and add these together. So 25 plus 3 is 28. 28 plus 2 is 30. So we're going to have 30x equals 180. And we're just going to solve this algebraically. So we're going to divide by 30, which is our coefficient. And x will be equal to 6 degrees. And that's it. So we're not done though. We need to find AOD, so we're going to plug that in there. So 25x, 25 times 6, and 6 quarters, how much is that? That's 150, so 150 degrees. There you go. And that's it. So measure of angle AOD equals 150 degrees. All right. So what should we do next? Let's see. Okay, oh, hold on. There we go, now it's working. Sorry, I had a little snafu there. All right, so this is another example we're going to try here, and there's some information given to us. We have this means circle F, by the way. This is the notation for circle. So in circle F, the measure of angle DFA is 50 degrees, which is marked here. So DFA is here, 50 degrees. And CF, which is here, is perpendicular to FB. That's why it's a 90-degree angle here. Okay, so we know this over here. These two would add up to 90 as well. All right, so we can go ahead and solve for these arcs. So remember, the arcs will have the same angle measure as the corresponding central angle. So if we can find these angles, we can then find the measure of the arcs. So that's what we're going to do. We're effectively going to find these first to make our lives a lot easier. So, okay, let's start with this. So we know that this is 90 degrees. We know that these two angles therefore have to be complementary. They have to add up to 90 because overall this would be 180. So we just subtract this from 90. What's 90 take away 50? That's going to be 40. So this is 40 degrees. These angles are vertical. They're formed by two intersecting line segments. Therefore, this angle would be congruent to that angle. So therefore, this is 50 degrees. Now this angle here, we know that these two are supplementary. Okay, that means these have to add up to 180 degrees because this is a semicircle. So 180 minus 50 is 130. So those are all the angles we need. Now let's look at the corresponding arcs. BE is here. This matches up with that. So this is 50 degrees. Okay. CBE. So CB is this one here. So we're going to add these two together. So this is 90. This is 50. So that's 140 degrees. And then ACE. So ACE, I'm going to use a different color here. ACE is going to be A to C to E, just like that. So we're going to add all these together. So this is 50, this is 40, this is 90, that's 50. So we have to add them all together. So 50 plus 40 is 9. I'll write down here actually. 50 plus 40 plus 90 plus 50. So 50 plus 50 is 100, 190, 230. So 230 degrees. Okay? And that's how you'd find those corresponding angles. Or arcs, rather, sorry. So those are the basics. I hope that was helpful. I'll be making another video or two on this stuff, so hopefully that helps. Hopefully it helped you guys out. Thanks. Bye.